Welcome to TechbrothersIT. In this video, we are going to take a look into the RDD. So in our previous videos, I did a lot of videos on data frames where we know that data frame is structured data and it has a column and rows, and then we apply different transformations and learn about that. In this series or set of videos, we are going to talk about RDD and apply different transformations and see how we can process data such as log data that's not well structured. So RDD Resilient Distribution Dataset is a fundamental data structure in PySpark for distributed computing. Now here is the definition. You can see that a distributed collection of data across a cluster, and you know that cluster has the nodes. A mutable, once created, it cannot be changed. So once RDD is created, you cannot make updates to it or delete part to it. What you can do, you can create another RDD from the already created RDD. So fault tolerant can recover from node failures. If node fails, it can be recovered. Think of an RDD like a list, but designed to scale across many machines. So here I'm trying to show how RDD will look as a visual. So you can see that RDD equal to these records right there. So we have different names and age, and then internally they are partitioned. So let's say if it is converted, an RDD is converted into two partitions. So what's going to happen, you have partition 1 that might be running on node 1, and the partition 2 will have these records, they will be on node 2. Each partition is processed in parallel across cluster nodes. And here are some key benefits of RDD. It's immutable, safe and predictable, easier to debug, distributed, stored across the cluster for fast parallel computing, fault tolerant, automatically recovers from failure, and lazy evaluation, delays execution until an action triggers it, such as count, collect, and first. So all those transformations of what we will apply on it. They are not going to run right away till you are applying one of these actions. So now here are the comparison between RDD and DataFrame. So let's say in feature we are talking about structure. So you know that the data frame is the SQL table like structured, so it has column and rows, but RDD list like, so it is mostly unstructured. And if you talk about optimization, you have to perform manual tuning for the RDDs, and here it is optimized via Catalyst optimizer. So that is the Catalyst optimizer in PySpark that optimize the data frame. Now you have API such as map, filter, flatMap. These can be used with the RDDs, and here we've been using select, group by, join, and other modes in DataFrame in our previous videos. So for performance, RDDs can be slower for common queries due to lack of schema information, while DataFrame generally faster for structured data due to the query optimization. So when you will use RDDs, so when you are working with the raw or complex unstructured data, so that's a good place to use RDD. You need full control over data transformation. So that's also one place where you would be using RDD. We are going to do a lot of examples on RDD, and you will learn all those scenarios where exactly we are using it. So where exactly the RDDs are useful for logs, text files, JSON, CSV files without a strict schema. So all those structured or unstructured, that's mostly unstructured, that's where you will be using RDDs. So perform the filtering, mapping, grouping before writing clean data. And machine learning pipelines feed the data into the MLlib for training or prediction. Streaming applications Spark D streams process real-time data as RDD batches. So and then finally you have RDDs power GraphX for social network or connected data analysis. So there are some applications you might be ending up using the RDDs. So let's go to the next video, and where we will create our first RDD and then apply different transformation, and you see the different use cases. I thank you very much for watching. I will put this code in the description so you can use it. Thank you, and see you guys in the next video.